Introduce our next speaker, Gowton Achaibar, and he's the COO and head of operation at Ericsson North America, a pinnacle sponsor of our event. Before joining Ericsson in North America, he was president and CEO of Ericsson India. So he's had a lot of experience in deploying really interesting technologies in different parts of the world. So it's safe to say that he knows a thing or two about fast-growing, high competitive markets. And so today, Gowton will be with us today, take a little time talking about LTE investments and what it takes to make them economically viable. So without further ado, let's hear it for Gowton. Gowton, thank you. Table's yours.
Good morning. Thank you, Steve, for the introduction. I think we heard quite a bit this morning already about LTE and some of the justification for why operators are moving towards LTE. Growth rates, new services, new capabilities, new features that are needed by end users. We didn't compare notes because we're from different companies, so I will share with you Ericsson's view. Hopefully it's not too inconsistent with the other views you've seen. I've looked at the data that they are presenting and it seems okay. So let's see what Ericsson think about what's changing in our wireless landscape and why we think LTE makes sense. And then I'll spend a few minutes to talk a little bit about some of the considerations in maximizing an LTE investment, if you have one or if you plan to make one. So let's start with the mobile traffic growth. Like I said, you've seen a number of slides this morning that talks about this. But from an Ericsson standpoint, we see over the next 5 years, mobile traffic growing by a factor of 10, sorry. The world today has 6 billion plus subscriptions with smartphones, and we see that growing to it's 1.9 billion today. It's growing to about 6 billion. We have 6 billion actual 2G, 3G subscriptions today globally. The data, we think, will grow by a factor of 10. And over this period, we see growth in average daily consumption going up by a factor of 4. In North America, we have over 320 million subscriptions today, so that's more than 100%, obviously, because lots of different devices are connected. The usage profile in North America today is around 15% on LTE, and the rest on HSPA, wideband CDMA, and CDMA. By 2019, we think 85% of the usage will be on LTE, which means that deployment of LTE networks will be fairly widely accomplished in North America in this time frame. So what's driving this data traffic explosion? We see video as a major driver in terms of this data traffic growth. And for those of us who use a smartphone and use video, we know that we use video quite a bit. I'm a big cricket fan, and the only way I can get a cricket broadcast is from ESPN Live from anywhere around the world, and I, in my car or at home, would tune into ESPN3 Live and watch a cricket match. And clearly, my use of video is more than whatever else I'm using that device for. And so we see video as driving this high data usage over the next 5 years. There's other types of services as well, web browsing, social networking, and so on. But video is a big part of what will drive the use. And in video, if you think about it, so networks today handle about 1 to 2 megabit of data speeds. To accommodate this kind of a data growth, we think networks have to get up to 5 to 10 megabit. And I think one speaker earlier alluded to this fact that the networks have to have much higher data speeds over the next few years to accommodate, the need for video. And what happens in a video transmission is that as you get further away from the site, your data speed drop, and the quality of the video and the customer experience is not very good. And so hence you have to have more more sites and higher data speeds per site. Oops. Because with video, if you go from SD video to HD video, full HD, you're almost quadrupling the amount of megabits that you're downloaded to your device. And like I said before, with the cricket example, I mean, we can envision a lot of live streaming happening here in North America with all kinds of different sports and all kinds of different live events. We can also envision that, you know, phones will have multiple screens and the ability to stream multiple streams simultaneously. And these are all going to be significant video hogs. So I guess my message is that video is a big driver, and video will be a big driver of data, and data overall in the network will increase quite significantly over the next few years. So why LTE? I think the first thing we need to understand is the spectral efficiency of LTE. If you compare LTE to, let's say, 2G technologies, well, there's no real comparison because the bits per hertz for 2G technologies are extremely low. For 3G technologies, you see that the bits per hertz are around 1 to 2. But as you get into LTE and you start to look at LTE with 2x2 and 4x4 and eventually 8x8 MIMO, you're going up in bits per hertz to 8, 16, and 20. So several orders over the current capability of the networks. And so this spectral efficiency in LTE is one of the big drivers why we think LTE makes sense for the data growth and the video growth that we're anticipating over the next few years. In addition, a lot of new applications will emerge that needs different types of performance criteria to be successful. I think one of the videos earlier mentioned oil and gas industry. Well, I was talking to a gentleman from the oil and gas industry recently, and he was having real problems with the application they wanted to run on the 3G network because the latency was around 1,000 milliseconds. In LTE, the latency is below 100 milliseconds, so LTE would have solved his problem, whatever that application you wanted to run. So there's a number of different things that need to be considered as well as we look at a network society. And you know, Ericsson have talked about 50 billion things in the future being connected to the network, and the whole concept of the network society using technology more broadly. These applications will have different type of performance criteria that are important. And a lot of those are supported in the LTE standard. LTE is also evolving. I talked about the evolution of the antenna technologies. LTE is an OFDM-based technology which is designed from day one in the standard to accommodate advanced technology concepts. You can also do carrier aggregation. So at some point in time, once the 2G and 3G networks are no longer needed to carry voice, those spectrum can be aggregated to create broader band within an LTE network. And we have already demonstrated with carrier aggregation in a number of tests that you can get 500 megabit per second downlink speeds on LTE. And so that's an important feature. LTE broadcast, so if you want to broadcast live events, you will need that type of capability with some type of a wireless technology. And then finally, at some point, as I said before, with the spectral efficiency of LTE, the 2G networks that are primarily providing voice will have to be turned off to reform that spectrum and to be able to use a much more spectrally efficient technology for that spectrum. So these are all the drivers that we think are, you know, contributing to LTE being the reason why it seems to be the choice for the mobile networks. So what are some of the considerations then in building and optimizing and maximizing an LTE network? Well, this slide is a little complicated, but the first thing we need to understand is LTE, unlike wireless networks today that are 2G and 3G, have to be managed from an end-to-end standpoint. You have to think of it as an end-to-end network because there's an IP layer that runs all the way from the core network through the transport into the handsets. And so that end-to-end nature of an LTE network means that you have to look at it from a design, optimization, and network management perspective as an end-to-end network. And what I mean by that is for network quality, for example, you can't manage the network quality just in, let's say, an RF domain by itself. A simple example is, Let's say you had a microcell in your home connected to an IP interface to get better coverage in your home, which I have today. Let's suppose that you have a problem with a microcell, and you only know you have a problem when you're trying to speak to somebody and they say to you, I can't hear you, or I'm losing every other word, what you're saying. So what do? You call the wireless company that provides the microcell and ask them to troubleshoot it. Well, there's not much they can really troubleshoot. The most they can tell you is turn off the phone, turn off the device. Do you have 4 bars? Do you have 5 bars? You look at it, it's not a problem with the RF network. You're standing right next to the microcell. So obviously the problem is in the IP interface to the IP provider. So you make a phone call to the IP provider, and what do? They ping the router, and they ask you to refresh your Yahoo page, and both work. But the service still doesn't work. The phone still doesn't work. Because the latency and the packet loss for a phone call is different than a Yahoo page refresh, and the ability for the IP provider to ping the router and see that the router is there. They have that capability, but they have no capability to look at the end-to-end service. And so as we look at LTE and LTE data performance, we have to be able to design for the end-to-end performance, optimize for the end-to-end performance, and then manage the end-to-end performance. And we have to do it at multiple levels. It's not only sufficient to have a good network performance, which we do today in 2G and 3G networks, and we know that we will then provide a good service to the end user, because the service is usually a voice call or some kind of a data connection. In an LTE environment, we also have to look at the service layer. Because while a Yahoo page refresh works, maybe a VoLTE call will not work, given that same network quality. So you also have to look at the service quality. So end-to-end network performance is important. Now let's take VoLTE, for example. So you have a new end-user device that supports VoLTE. The radio network has to be designed to support VoLTE with both a consideration on densification as well as the feature set. Now, the design consideration is more than just having more sites. You also have to think about the heights of the sites, whether the radio should be on top of the tower to give you more 3 dB more output, the type of antennas, because a lot of networks today are designed with mechanical antennas. In LTE, we probably need to think about electrical antennas, because electrical antennas help you control the interference in an LTE design. And now I'm getting a little technical, but for VoLTE, it's important that the signal-to-noise ratio is very good. I was recently in Korea and drove around the Korean network for an hour and did not have a single problem with either LTE call or a video call, because the signal-to-noise ratio was greater than 10 dB. A lot of our networks here are hovering around 0 dB. And so we have a ways to go to get to that level. And one of the challenges we have is that we have a lot of LTE networks being designed on top of CDMA. And that's good because you're reusing the physical infrastructure. But what we need to consider is that in CDMA, overlapping coverage is a good thing because you have 3-way handovers, 6-way handovers, soft handover. In LTE, overlapping coverage is not a good thing. It creates interference that reduces signal-to-noise ratio, which creates a performance problem in the network. So the design of the network is important from an RF standpoint. The design network is also important from a transport standpoint, because your jitter, your delay, your packet loss are all have to be considered as we look at the transport network design. And then in the core network, the IMS network and the EPC network also have to be designed and optimized. Because in the end, a VoLTE call is not a single domain by domain call. It's a call that cuts across horizontally across the network. And so once the network is designed and optimized from end to end, it then has to be managed from end to end. And so, we have the standard alarming interfaces that detect there's a problem, but we probably also have to have tools that look at the integrity of the IP network and tools that look at the service layer to see what's actually happening in the IP frames to ensure that the different services we're running across that network have the right service quality and the right criteria in terms of what you need to deliver good service. So the design, the optimization, and the network management all have to be looked at. And to fully maximize the investment, all of these things we have to get right, because a network that has higher signal-to-noise ratio in the RF domain means that you probably have to add more infrastructure. Well, if the network is optimized, you can reduce the number of sites that you probably need. So to summarize this then, what I said was video and data traffic growth continues to expand rapidly. We see a lot of forecasts from a number of companies this morning that propose that this will happen. I think it's happening. It's happening around us. LTE is more spectrally efficient, in fact, far more spectrally efficient than 2G and 3G technology. So ultimately, at some point in time, we have to evolve to VoLTE because that's how we will maximize the use of all of the spectrum that we have. LTE network cost is not just the electronics, but it's also all the infrastructure. And so if the electronics is not used optimally and properly designed and optimized, there's a significant amount of cost that is going to be wasted in infrastructure. So maximizing LTE network bring benefits to delivering higher bandwidth to accommodate the data growth, better quality in order to move towards VoLTE because we have to at some point move towards VoLTE to recover all that spectrum that's so valuable. And then it allows us to reduce cost in both, you can say, CapEx and OpEx. Managing the LTE network then will require some investments in tools and competence in people, and I think one speaker this morning talked about partnerships. And so when you look at LTE, you really got to think of all these in a totality as you make that decision. Thank you.
All right. Put this over to Zion. Thank you, Gowton. I understand access to LTE is half the battle. The other battle is manage it effectively and monetizing it. So thank you for your views. Why don't we